What's up everybody, it's Parker with BI Elite. I have an awesome video today showing you how to scale down your data to remove the effects of outliers. For example, in this COVID-19 dataset, we see that our data is very skewed towards New York, given that New York has around 60,000 confirmed cases at the time of recording this video, while the other states are usually less than 1,000. So we see that New York shows up with a lot of values, but you don't really see much color coming out of the other states. So I'm going to show you 3 ways that we can handle this. The first 2 ways are going to be really quick, and then the last way is probably a preferred way to handle it with a more statistical approach. So firstly, the first way that we can handle this large discrepancy between the scale of the max value and the min value of our data is we can simply edit the formatting settings of this map that we're showing, and we can set a center value that is going to basically round the center color around a number. So if we arbitrarily select 3,500, we see that we now have a nice scale on this chart. So this works really well. The only problem with it is that it's not dynamic. With this data set of COVID-19 cases, you can expect that it's going to grow over the coming days. So we don't want to set the static number, but this does work if you're just showing a visualization for a one-time purpose. So I'm going to go ahead and get rid of that. Option number 2 is to use a log scale instead of a linear scale. So you may have used log scales in the past, but I'm going to show you. I just created a basic calculate column for a log scale, and it's simply log of my confirmed cases to the base of 10, and you can use whichever base you want. It really doesn't matter, but you can see what it does to our data here. It puts it in this log base 10 scale, so it's really ranging from 1.9 to 4.77. It's a much smaller scale. And now we can look at that in a map visual. This is using that log scale column. So log scale by state, and we can see that our colors have come out a lot better. We still have New York that's red, we have New Jersey, which is in second place with orange, and a lot of other middle values tending towards that yellow and orange color with a little bit of purple. So this works really well out of the box. The only problem with it is that it's teasing out a little bit too much yellow, I think. I'd rather put more emphasis on the states that have a higher value and a lower value, similar to what we have here in this final version here. So I kind of want to show more of the purple in the states that really don't have as much cases as other states. So we're going to do that with our third option, which is to look at the mean or the average of our confirmed cases and calculate the standard deviation of our confirmed cases and make a decision on how to handle it. So we'll do that in a couple more calculate columns, and you can do this in one measure if you'd like, but I just put in calculate columns for ease of understanding. So we're going to calculate the mean of our confirmed cases. That's simply the average of our confirmed cases. And take note that these are the same values all the way down for every row that we have. And that's because we are not using a calculate function in this calculate column. It doesn't have a sense of row context, meaning we're going to get the same value for each row in this table. So we have an average confirmed case value of around 2,800. And then we're going to calculate the standard deviation as well using another function that makes it nice and easy. And that's stdev.p. And we throw in our confirmed cases, and we get the standard deviation of our confirmed cases. And standard deviation is a way to explain the variance of our values, and we can see that we have a standard deviation of around 8,000, which is very large compared to our mean value. So since we have some large values like New York and New Jersey, it's really skewing our standard deviation to be much larger than the mean. So what are we going to do with these 2 calculated values? We are going to use them to say if our confirmed cases is larger than the mean plus a single standard deviation away from the mean, we want to kind of convert that down or scale that down to just use the mean plus standard deviation. And you see that's what we do in the scaled cases column. So we take our mean, which is just recalculating the average of all of our values, and then we're returning an if statement, and we're saying if the confirmed cases is larger than the mean plus the standard deviation, which is somewhere around 11,000, then we want to return that same mean plus standard deviation, else we'll just return the confirmed cases. So you can see that since New York and New Jersey are larger than the mean plus standard deviation, we're just returning the mean plus standard deviation. And doing so, we're able to achieve the visual on the right. We have New York and New Jersey showing up in red, and everything else is kind of magnified, and it's bringing out some of those middle values and showing a little bit of shading differences for values that are smaller, yet a little bit larger than the minimum values. And we do have some flexibility over how we want to perform this calculation. Instead, if you don't want New York and New Jersey to be similar, we can basically set our bounds to use 2 standard deviations away from the mean instead of 1. And it's going to basically extend the limits that we're allowing our scaled cases to be scaled down for. We can look at what that does. You'll see there's a little bit less yellow in the middle, but now we have a little bit more distinction between New York and New Jersey. So this is good because it's going to be dynamic as your new data comes in. I would say it's better than the static method. It might be better than the log method as well if you're looking more for a representation showing a little bit more towards that lower end scale instead of the yellows that were popping up in the log scale. So I hope you like this video. I hope you can use this in your future reports. Maybe if you're building a COVID-19 confirmed cases report as well, you might be able to use this methodology. So if you like this video, make sure you check out the accompanying blog post, and I will see you in the next video.